Hey Scotty, this is Miss Tracy here. So let's look at the problems you got stuck on in lesson 80 first. So here's the first one. The number of acorns on the ground increased 240% during the storm. So the key word here is increased. So that means we have to add that to the original amount. 5,400 acorns were on the ground before the storm. How many were on the ground after the storm? So if the original amount that was there before increased this much, we have to kind of picture it in our heads that what was on the ground first is the 100%. So we have a before the storm and we have an after the storm. Those are our two events. And then we have the percent, and then we have the amount or quantity. You could use quantity there also. Let's use quantity since after starts with an A. All right, so quantity. So before the storm, whatever was there was 100%. After the storm, the amount increased. So that's going to be plus 240%. So what was there before was already 100%. 100% plus 240, that's going to be 340%. So this is the amount after. We have 340% after, right? We don't really have to have the percent signs because it's already up here at the top. It's kind of redundant. All right, so that's going to equal the quantity. Now the quantity before was 5,400. What we don't know now is the quantity after. So this becomes our cross multiplication, our proportion statement. Now I'm assuming, because a lot of students had the same problem, that it was the addition of the 240% to the 100% is where you probably got stuck, because a lot of students put 240 down here instead of 140. Instead of 340. So when we cross multiply, we get 100A is equal to whatever 340 times 5,400 is. Let me get my calculator. So if I do 340 times 5,400, we get 1,836,000. So 1,836,000. Divide both sides by 100. Then A is going to be equal to 18,360. That's how many acorns we have after the storm. Okay. All right. So the key factor was to see this word increased this much. So you have to add that back to the original, which was 100%. That's probably where you got stuck. All right. So let's look at the next problem. All right, here was the next one. And I don't know if you made it to class that day or not, but there was a correction in the lesson video, and I have since gone back and corrected the video. But it says the number increased from 40 to 280. What percent increase was this? So we're just talking about the amount of the increase, right? Not the total. So we've got to find the amount of the increase by subtracting 280 minus 40. The amount of increase is 240. So this is the amount that we're going to reference. So we build our table and we say the percent, the original amount, the original number is always 100%. And the new number, or the increased number, let's call that increase just for continuity. The increase was 240. So the quantity, the original quantity was 40. I'm sorry, I put that in the wrong spot. We don't know the new percent. The new or the increased amount was 240. We had 40, we added 240. It's not asking about the total, it's asking about the increase. So that is where you have to do some subtraction. So we're going to cross multiply 40 times P is equal to 24,000. Divide both sides by 40. The percent is equal to 600. 600% is the correct answer. All right, let's look at the next one. Okay, so I'm not sure how you did this problem, but I'm quite certain this is not the answer. I think you just got frustrated and typed a bunch of stuff. And I'm sorry if you got frustrated. I know that sometimes this stuff is hard. Don't take it out on the keyboard. So hopefully you didn't bang too hard on it. Marcus's daily caloric intake was 2,200 calories. Okay, so we're talking about his calories. And the, let's do percent here. The original is 100. You can always start it like that. On his birthday, because of Barbara's red velvet cake, his caloric intake increased 35%. So that is the amount of increase. How many calories did Marcus consume on his birthday? So in this instance, it's asking us how many calories did he consume on his birthday. It's not asking us how many more calories he consumed, how many calories total, all of the calories. So we're going to look at, that's the original amount of calories, and this is the new amount of calories, or we could call those birthday calories, right? We know that the amount increased 35%. So 100 plus 35 is 135%. This is the amount of the increase, or the total amount that he had, I should say. It's not the amount of increase. This is the total amount of calories compared to his original amount. So the calories that he had, originally, he would have 2,200. We don't know how many he had on his birthday. So we're going to cross multiply. 100C is equal to, and I don't need the percent sign, 135 times 2,200 is 297,000. Divide both sides by 100. Number of calories he had on his birthday was 2,970. So that is what you have to read what the problem is asking you for. And if it's asking you for just the amount that increased, then that's what that's the percent you put down here. But if it's asking you for the overall, like how many calories total did he consume on his birthday, it didn't say how many more calories did he consume, then that's asking you to split it and tell just the new ones, the additional ones that he had. So you've got to be able to read these word problems and understand the language that's being used and what it is inferring, what it is asking you to solve for. So because it was asking for the total amount of calories, we had to add that 35% to the original 100 to see what the increase total would be. So that's how you would do that. So pay attention to the language. The language will trip you up every single time because we have a hard time flipping the switch between words and numbers. So it's something that you've got to pay attention to and be very careful about understanding fully before you set up your problem. All right, let's move on. And I think that's all you had for lesson 80. I'll double check. Yeah, so that's all you had for lesson 80. This is for quiz 19. So again, we're going to be setting up some type of a table and organizing our information so that we can see it better. So let's read through it. A university wants to have 1 4/5 computers for every student enrolled. That is a rate. When you see for every, you know that is a rate, one related to the other. So 1 4/5 for every, that's computers, for every 20 students. That's our rate. So I'm going to rewrite this. This is computers, and this is students, and this is the rate. So the quantity, or the number, whichever you want to say that, is going to be an equal fraction, an equivalent fraction that allows you to set up this statement to find the unknown value. So the university expects to have 5,800 students. So that is the amount you put on the student line. So we put 5,800 here because that's the students. The students are in the denominator in this setup. So we don't know how many computers we need, but we do have an equivalent fraction here, or a proportion statement that allows us to cross multiply. So algebra hates mixed numbers, so we're going to turn this back into an improper fraction. So that would be 9 over 5 over 20 equal to C over 5,800. So we're going to, let's cross multiply 9/5, and I'm going to turn this into a fraction by putting it over 1, because you can turn any whole number into a fraction by putting it over 1. That's just going to help me multiply better. And then this is equal to 20 times C. So when I do this calculation here, I'm going to get 9 times 5,800 is 52,200. So I've got 52,200. 5 times 1 is 5. I know this is divisible by 5 because it ends in a 0. So I'm going to go ahead and divide that by 5 before I solve further. 10,440. Now I can do the next step, which we know this is 20 times C is equal to this. So I'm going to divide both sides by 20. Divided by 20, 522. That's the number of computers. So you can see how you just need to progress with, it doesn't matter whether you're given a fraction or a decimal or whatever that mixed number is, you just put that value in. And then you handle it when you get to your cross multiplication in the way that you need to. We had a fraction times a whole number here. So we just turn the fraction, or we just turn the whole number into a fraction to make it easier to see. Then we go ahead and perform the division implied by the fraction, because the fraction bar is just a division statement. We know this. So then that gave us a number that we could divide by 20. So you just follow it through, knowing what you need to do the math. Worry about the operations that have to happen. You know what they are. Just apply them as they make sense to do so. All right, let me see if you have any more problems from this quiz. All right, here's another one from this, and this may be your last one. I'll check and see. But this is to find the volume. The volume is always found when it comes to right shapes or right geometric shapes that are not pyramids, cones, or spheres. As long as it's not a pyramid, a cone, or a sphere, volume is found by area of the base times height. Every single time. If it is a pyramid or a cone, it has a special formula, which is area of the base times the height divided by 3. If it is a sphere, which we'll do in Algebra 1, it's like 4 pi r cubed, something like that. So we're not doing those right now, though. We're just doing a straight up and down tube, right? A cylinder. So that means area of the base times height. We don't have to worry about these just yet. So we'll just erase them. You'll get to those eventually. It's not necessary to worry about right now. So the area of the base, we have the area of the base is a circle. And we are told that we have a radius of 4, and it's in inches. So the area of the base is going to be the area of a circle. So the area of a circle is pi r squared. So pi, and then our radius is 4 inches. So r squared is 4 inches times 4 inches. And then we multiply that, this is the area of the base, times the height. So area of the base, let me get my highlighter. Area of the base, right? Height is 8 inches, as told by this number right here. So that is going to be your height. So that's how we do this calculation. We are going to say 4 times 4, which is 16, and I can't do 16 times 8 in my head. So 4 times 4 times 8, right? 4 times 4 times 8 equals 128. So 128 times pi, because it's a circle, inches, 1, 2, 3, 3. That is your answer. Okay? That's all you have to do. Remember, the area of the base for a circle is equal to pi r squared. So that's what's right here in this yellow part. Okay? And I usually like to draw a little radius to clarify that that's a circle and not a 0. All right, that is all for that problem. Let me see if there's another one. All right, so there's 3 more, including this one, so let's look at it. So we have got some denominators that need to be made common, right? We could probably agree that the common denominator is going to be 10 because both 2 and 5 are factors of 10. So it's really easy to get there. So what we're going to do is we're going to change these denominators and make them all 10. So we're going to rewrite it. So I need to multiply this whole fraction by 2. So it's going to be 8 over 10 times x minus, we'll multiply this whole fraction by 5, so it'll be 5 over 10 equals 23 over 10, right? Okay, so now I can add 5 over 10 to both sides. This would cancel. 23 plus 5, that's going to be 28 over 10. And that's going to be equal to 8 over 10x. Now, the way we free this fraction, we are multiplying x times 8 and then dividing it by 10. So we have to do the opposite. So the way we do that is we multiply by the inverse, or the, not inverse, reciprocal fraction. So now we multiplied by 8, we divide by 8, they cancel each other out. We multiply by 10, we divide by 10, they cancel each other out. So it'd be 80 over 80 is equal to 1, right? But whatever we do to this side of the fraction of the equation, we have to do this side of the equation. Just like that. So now 80 over 80, that cancels. So now we just have 1x. And then we have 280 divided by, actually, you know what? I'm not going to do that because the 10s cancel. So I'm going to say 28 over 8. I just went ahead and reduced it early. And then looking at this, I know I can reduce it even more. 28 divided by 2 is equal to 14. And 8 divided by 2 is 4. Well, guess what? I can reduce that again. And that would be 7 over 2. Hold on just a moment. Sorry about that. I had a phone call come in. So we reduce the fraction all the way down until we can't reduce it anymore. And then this would be our final answer for this problem, 7 over 2. All right, let's look at, you had another one. All right, this is the next one. It said that you need to simplify. So the first step whenever looking at any of this is we can't do math with mixed numbers. It's just almost impossible with this level of we need a certain level of flexibility and maneuverability. And you just can't get that with a mixed number. So the first step is always to get rid of those. So 9 over 10 plus 5 over 9. Get rid of the mixed number. That's 5 times 2 is 10, plus 2 is 12 over 5, minus 1 over 4. So there's a couple of different ways you could approach this. You could multiply this fraction times this fraction, and then get a common denominator. Or, because they're separated by a operation, you could perform the operation first and then multiply whatever the remainder is. So I think that's the easier way to look at it, to get it simplified as much as possible within the parenthesis first, and then look at multiplying on the outside. So let's do that. So the common denominator is going to be 20. It's going to be 9 over 10 plus 5 over 9. And if I multiply this by 4, I get 48 over 20 minus, and I multiply this by 5, and I get 5 over 20. So then that becomes 9 over 10 plus 5 over 9 times 43 over 20. So that's a little bit easier to deal with, right? Now I know that 20 is 4 times 5. So I'm going to rewrite that as 4 times 5. Right? 4 times 5. That lets me cancel the 5s. And it just makes it easier to do the math. So I don't have such big numbers to deal with. So I'm going to now do the calculation. Let me scroll it up a little bit. 9 over 10 plus, that's going to be 43 in the top, and then 9 times 4 is 36. So now this is a lot easier to deal with. So I'm going to have to find a common denominator between these two. And the way to do that is to look at factors. So this would be 2 times 5. This would be 6 times 6, 2 times 3 times 2 times 3. So if I multiply this one by 12, and I multiply this one by 5, if we cancel out this one factor here, if I multiply this fraction by 5 and this fraction by 12, we should get to the same number. So that's what I'm going to do. 5 times this is 45 over 50. Oh, I'm sorry, I'm doing it backwards. 12 times this one. 12 times 9 is 108. 12 times 10 is 120. And 5 times 43 is 215. And 5 times 36 is 150 plus 30 would be 180. So I didn't do something right. Let me look at that again. Okay, so I'm going to multiply by 18 on this side. So I know 180 will work. So we're going to multiply by 18 here. 9 times 18, I don't have a clue what that is. We'll use the calculator. 9 times 18 is 162. 162 over 180, because 10 times 18 is 180. And then I'm going to multiply this by 5. So 5 times 43, again, is 215. And this is 180. So, all right, now that works. Now that I've got them multiplied by something to get to a common denominator. And you might have to try a couple times like I did to just, when you've got these weird numbers like this, these weird denominators, you know they relate, but you you can't figure out how to do it. You just have to practice a couple times. What if I did it by this? What if I did it by that? Figure it out, okay? So let's add them together. So 162 and 215, I like to stack them just because that's the way my brain works. That's the way we did it when I was in 7th or 8th grade, and it still is a good way to do it. So 377 over 180 would be your answer. And you can't reduce it because 377 is, I don't think it's divisible by 3. Let's see. 3 plus 7 is 10, plus 7 is 17. 1 plus 7 is 8. That is not divisible by 3. So we can't really do any reducing here. I think that's the answer. Let me double check. Yes, that is the final answer. We did it right. So 377 over 180. That's what you got to do. All right, let's look at the last one. All right, here's the last one. So we've got 9 times 10 to the negative 3. 3 times 10 to the positive 3. Answer in scientific notation. So 9 times 3 is 27. Negative 3 plus positive 3 is 0. This cannot stay like this, though. We have to have it in scientific notation. So we have to do this. So we move it back 1, or move it forward 1 to the front of the number. So it's going to be plus 1. So 2.7 times 10 to the 1, or just like that. This would be correct. So the way we got 0 was we added these together. Negative 3, positive 3. Negative 3 plus 3 equals 0. All right. And that would be the final answer. 2 times 7, or 2.7 times 10. 2.7 times 10 to the 1. Or just 27. But it does say answer it in scientific notation, so it's probably looking for this one or this one. Let me double check. All right, so it is looking for this one. That's the one it wants. I'm going to add this in as a possible answer because by its very presence there, 1 is understood to be the exponent. So I'm going to add this in. This is what's in the system already, but I'm going to put it in without the exponent of 1 because it means the same thing. All right, that's all the ones you had problems with. If you have any more in the future, please ask for help. I'm glad you did this time so we could clarify some stuff and get you all on the same page. And that's all I've got. I'll see you Thursday. Have a great rest of the week.